number of branches. Number of branches raised to depth is your exponential time. And if you want to find out space, space means what? How much is the space? This is what space is covered, right? All these nodes are representing problem space. So how much is the space? So B into N. So how many branches are there? 1, 2, 3, 4, 5, 6. 6 branches are there. And then what is maximum depth? Multiplication will be giving you space. Simply this, how much is the space of this array? So this is what depth, and these are branches. This defines the space. Similarly, time, that means how much time is required? Exponential time. So number of branches are there and number of depth is there, depth is more, obviously time will be increased. If there are so many branches down there, then time will increase, right? So number of branches and how much is the depth, right? This will be defining your time. This is what DFS algorithm or DFS properties. Now if you are having notebooks, you can solve this problem. Take snapshot, and if you can solve this problem, I will admit somebody is there waiting. Snap and try to solve this problem. L is the goal node, so make structure generally incoming node and outgoing node. This is how we process. Generally this is made for us, right? Generally in a problem there is only one branch, but for our simplicity we are making this is previous node, this is next node. So out node, right? This is current node. So this is branch, and whatever going out is written to be here. So this is what our simplicity, one of the simpler method to solve the problem. See, this is how solution is there, right? So if you want, you can take solution also, the snap also. So A is going out, right? B and C is there. Then B is there, stand on B and take next. Likewise, look at goal, that direction must be taken, right? Look at goal, right? Your goal is at L, so you must proceed to C. So you must expand C. Look at direction sense also. This is one more example. Take snap, you can solve this. Any questions, any doubts? These two examples are there. Once again, I am keeping my frame steady. This is solution of earlier problem. This is unsolved problem. One more unsolved problem is there. You try this and find out path to the node N. Now any questions, any doubts here? In depth first search. Any questions, any problems? Hello? Any questions?
No, sir.
Okay.
Hello, sir.
Ha.
Sir, I have a question about that completeness. So whether this algorithm is complete or not?
Now DFS is not guarantee optimal solution. This algorithm is not complete, right? Because see that right now I know that is what direction sense we are saying as a common sense, right? So that I am selecting this node. You must understand that. So if I take blind, this is blind search. If I take B first, then it will go to this branch and it will come here again, rejecting. It will come back to C, right? So here, that's why iterative deepening or some advancement is done so that we can have here. But generally that direction sense we apply. This is what drawback, because it doesn't guarantee the solution. It is not giving optimal solution, right? But whenever list of node is very large, your data is very large, or your search points are very large. We have to go in blind. For example, I am searching, a search engine is there and I am searching an image. So many times I do not get exact match of that image. If you, many, all of you are doing image search, right? So you put a image from Google Lens or any other app to the search engine and you try to match that image. Now, really we don't know know all the details of that image. Now what algorithm is doing? Algorithm trying to match maximum contents. So it will be going in the depth, right? But during all this journey, it is trying to match everywhere. During all this journey, there is no guarantee that exact match will be found out. This is, I am talking about random images, not defined images like face recognition or any other application. This is on large, very large data. Large data means very large data. But we have to search in depth. We have to go first to the depth. And then we have to check that whether my solution is having. Now, second, our strategy is breadth first.